Okay, so Master Mason notes. So we've tore up a lot here, hitting some notes tonight on doing up the Tomb of the Unknown Mason. You know, you're kind of sitting in it tonight. It's the big marshmallow for air acoustic flutter. Uh, me, I'm hitting it up. Oh, I got the whole rainbow today. Hooked it up. So, we can do a lot of different things for whiteboard training on the stone, on the palette. First you get these because they're the marks that you need to do it in. Then you do it on palette counts to what they are, or, any kind of red call, blue call, first, second operation to loading the stones. Whatever shift to the prism that refracts the causal speed of the stone mill. You can do that right there. Hitting that bow note, them broadheads, check it out. Do different techniques. Giving your formation, maybe a different housing so you don't break as many flints, or have a different system that works more appropriately, because I've been going through a few of them, dinging them up real good, giving them the incident report. But yeah, I usually chew them up pretty good. It's a good one. Nice light, extra springy, kind of a little bit older, beat up. This is the first one they had there. Somebody was using it. I don't know. My very first flint, I've used, let's see here, both sides of a flint. You should be able to do this correctly. And then flip them over if there's any heavy sides. If you're doing it correctly and you got the right strike, she just hits. But anyways, we're loaded up on that because that's been giving me issues on the test. It's not that they're not there in my pack. Let's see what I got here. It's not that they're not there in my pack, but I like to have them in my pack. Come prepared with your own gloves and chisels and safety goggles. Not to say that these ones aren't good. They like to scratch out most of the time. You get a little bit of muddy or mud on your shirt and you go to clean them off because they're dusty, or fog or whatever. You just have them up in your gear. And then the fog ones are too big or wide. You get into some of this other problem. But anyways, also I got myself a kit. Surprised one hasn't come by me around on the floor yet, but it's no longer an issue. We got the torch head cleaners. I know where there's another torch head on the floor, almost brand new. Nobody's using it. I might switch that off come Monday. Just give her a good poke when she starts kicking out some glass real good. Maybe there's something choked up in there. Usually a bent over nozzle or something like that needs to be filed out because it's going to kick less as good as anything else. If you're hitting those notes on the regular, come in tomorrow morning. And, I saw yesterday, so that was the causal parallel that was the same, X and Y. And tomorrow when I get in there, we're going to check the saws first thing in the morning. We're going to check the pallets on the walkthrough, make sure we see what's standing 18, 24s, make sure that correlates to what's in my stack to turnover, start to adjust the system, make sure that always comes over, because, it kind of hurts when the station's stacked out wrong, or I got to burn the wrong rock at the wrong time. I have to build a lot of overhead, constant pump that instead of properly run the notation as safely as functionably as the up the down says. This has to stop because bringing rock more over, you can only stack so much inside of there. Work it clean to the operation of programming and loading saws. Not that you couldn't stop everything and do it differently if you've seen that one operation and tracked it before against standards and statistics that output the best, safest result in the physical net that straightens that off to here's all the XY grids and nice little cube matrix of the timelines of those positions that really determine what physics is there. The epsilon fair, Hawkins Harry black hole radiation, heat, thermodynamics off that person, usually sweat and working joules. Working the Mayan Hydron Collider clock, just the hamster wheel. So there's a lot going on with that. Again, there's time in the function. I like the 90-day stone method variable to sentinels, and you're going to be walking up and down this looking for dirt underneath it because it comes up to the play when you're ready for it. Bang, there it was, and I'm right on it because that's the turnover to the adjusted system. Had to do that one, flip it over to the cameras. That's the count on these. Had to turn the lips around, throw Princess Peach. Mario, all the stars and like little Cubones coming at you uh, from whatever moles. Honestly, Triple Agent to the standard of what that does, where you're going. Yes, Sarge, I am eyeballing you, matter of fact. I'm eyeballing your boss, too. But you can't say that there. Honestly, you're going to have some maps and strategics to watch them do that. Like I said, usually if you're running, they're running with you. And that's an OP on the player like that. It's good to just hit that apprentice phase until you're really good with those numbers and adjust over to the proper calculus of that form. Then you can make decisions. Some of that's a little hot on the sharps officer side. I get the same result a little differently given how I train things, and I bet you if I go looking at that, that will. And if I'm willing to take it on right now, maybe. That might be other things going on. So, honestly, with those kind of, what else do we have in there? We had a lot of stuff. We had some, the Basilisk, the AI. Again, Tomb of the Unknown Soldier, Tomb of the Unknown Mason, in Paris Island, given detail 1 or detail 2 to the Air Force's air turbulence equation against reconnaissance on the mill floor, and the space team logistically time modeling the entire chessboard out to the mass gap of that situation, really defines all the general numbers in the forms. These are the constants, Euler's number, how to adjust it in the mainline training practice. You might be able to mass it out, M2 after that. Everything is gravity after that point. G, I, if you want to turn those over. F equals y over x or y equals f over x, trying to figure out the reverse time analysis, the compactified, superposition of the gluon, quirky bits about any of that. Those are kind of those grids in those forms. However, in the stone melt, parallel straight lines and how they're going to act, x and y hedging onto the curve of the entropies of those states, and how you hedge the bets on the margin to the statistic analysis, the population of rabbits in the area, or what that rabbit may look like given that swing or adjustment of the tides, topography, elevation, any kind of XYZ Mobius strip on how that affects the system. It's kind of about the world's hardest problem in the way the sheet is at the angle to that system and how the working joules roll the ball of that specific size and mass inverted from the numbers of that point, saying X was the number of rookies of salty trains, how to get a lot of those E7s down in the stone mill, just that number to the high-end operation that teaches a function in case they get crossed on that, and a way to adjust that model. A lot of times the stone mill is not saying something, but eventually that radiation comes around. Lots of bars, little things on the stone mill floor that make it not safe because it's away from that gravitational number, which is the proper notation, instead of working and then taking it easy and trying to say, it's one of those things, trying to do it for safety here. Take your time, but pump through. Don't burn anymore when there's that kind of system on the rotation around. There's always time to clean. There's always time to grease rollers, do something, look at the mechanics, do spreadsheets, do a safety unit with the team X, Y's, and Z's for the units of the orders we're about to take on. So those are the main operations that I would know as the thermal or 5s, 4s, 3s, what kind of rocks rolling in, how to do the math, because that's the X that I needed, the wiggly squiggly compact line. Instead of it being straight in the triangulation of sine and cosine or P versus NP problem, college models versus, you have to be careful with some of those teachers. I don't like to test the problem or do some higher orders of thinking. And realistically, in the stone mill, you have all those for colony collapse in bees, or wave collapse in Lego for distended dark matter and redshifting problems, beginning to see that stonemason fall away from a better model of that original 90-day standard, because now they have to start that from a clean system with somebody like Salty rolling in to have to adjust that, and it's probably going to be pretty sharp. Both players are probably proficient in what they do and how they act in a very specific system that entropies what that system does. Given the Tomb of the Unknown Soldier and how far the entropy is against that to the Tomb of the Unknown Stonemason, whatever line you're living on that, and how that operation posed dollar bills to your system, adjusted reciprocal into that R1, saying the moves, backtrack, reverse engineering is an area problem, but not necessarily based on that square number, 0 and 1 or 40 miles an hour out to 80 miles an hour on the angle, clearly going to correlate to 120 on this trajectory and a net force where no other acting system n1 half would divert from that wiggly squiggly line given that angle, and how work would function or how physics would behave given that function operator. Fractal. Um, it's testing out some of those theories where they work in there and how they behave given that system. Again, a lot of the times you hear things about spectrums and, people, it's got a little bit of the devil to it, that acoustic flutter, or aerocrastic flutter. Given how can somebody explain it, what's the main model for where it's going, the higher entropies of taking something like that, all that math with Carl Sagan and Neil deGrasse Tyson, and early on, why you would want to take a highly enriched system like that is privately above certain standards that calc off on variables that have high end results on what those things, especially if they really are fundamental with those types of maths and understandings of how that produces a function, or understands how what the result, or tuning in the feeds and speeds as an expert from the outside could walk in and say that laser has issues here, and that's that wave function bit, or where the x derivative, AU over AV, air turbulence equation, baryonic harmonics, Bose-Einstein condensate, that is the stone mill, that makes those feeds and the speeds not as accurate or proficient as square from the Sawyer's position, or tight on the thermaling path, or adjusted models to pop that stoichiometric ratio off, which are gas law principles of the FMA object in a net force that has zero resistance against it and zero entropy to what it can do on the output against what its free will might turbulence flow, that idea, to what the top end model is without a causal system. It says from that position, the entropy wasn't this defined box, it was just X. You had this many pallets a day, this many turns, those days are consistent over these radiants. M1, M2 over R1, F1 plus F2 minus F1. And how that would look given more dimensions, or how they parallel these things, share the same prime function, local key that says that's a 1 or a 0, or in that 1, 0 electron position to the strong force, weak force. Its electron acts to certain positions that the neutron does, or how it connects. Mercury does this in chemistry, if you like the periodic table versions of chemistry in college. The old guy with the fluffy hair, he kind of messed it up a little bit, equally to Drill Sarge Smash in your bag, or me as a stonemason. This is one of those tables, I'm going to kick it on you. They're small rock, you're running fast. This is the system, better you do it, and then I'm going to make sure you're running the system for things that will do this, or opportunities, because that gets to be me here instead of you walking in and out. And then eventually, if you're real good, you will be able to clean in inside out of the saw while it's running, because you'll be trusted to do so and out of the way, because all of the mechanics are there to make it absolutely safe, regardless of what OSHA says. That's how the physics on the money of the engineering here does to the proper mechanics, all those little mousetraps, dark energy wells, and observations that space and time really are the only thing left that adjusted that. And when that physics becomes something relative, you could say that's a solar body, or a mass under that same kind of calculation, parallel straight lines relative to the squiggly wiggly, because not necessarily causal light. It's not useful to me there. Here it's useful to me too is the causal light speed of a pallet of tread that sits in this building, because that's the neutrino planes that I'm playing X, Y, and Z with here, to say here's the first term, the second term, X, Y, Z, A, B, C. This is the steps in the process, is how to look at that with the Lorenzos to adjust the system to determine the proper mass calc. Just V at the top, the velocities, the acceleration, whichever one of those pins off the bill, the square root of that, which are again fundamental forces. Where's the heat and electromagnetism, plasma state, all that, which is the neutron proton of the space-time, how it's acting at that trip point, which whether that's the electron position or whatever, the velocity of that, quirky gluon action that it does given the state of matter and the phase oscillator, which is probably a very strong force, and it's right there, right then. All the things it could do is doing this right now, which is gravity. This is observable. That's the how do I beat that? It's a very weak force. I can see it do a thing, but to really break it down and dimension strong forces, weak forces, this thing has a byproduct is turbulent flow to adjusted X, Y, Z systems again, M1, M2. Catch you on the next one.